There's two types of questions that you get about rotations. One is to carry out a rotation, but the second type can be a bit trickier, and that is to describe a rotation. I've got 4 questions on this sheet, and you can see the diagram with the triangles numbered 1 to 5, and if you're asked to describe a rotation, the tricky bit is to find the centre. So let's look at each of these. So if you can see the questions, the first one is how do you get from triangle 1 to triangle 2? I've got my tracing paper and I have pre-drawn triangle 1 on the tracing paper. Now, the question on this sheet just asks you to find the centre, the coordinates of the centre of the rotation. But while we're here, we'll just think, how else would we describe the rotation from triangle 1 onto 2? Well, hopefully you can see that it's exactly the same size and shape of triangle, but to get from here to here, it's been rotated, hasn't it? There, so it's the same orientation now as triangle 2. So what's the angle it's gone through? Well, if you look at the rectangular, roughly rectangular tracing paper, it's turned through 90. So 90 degrees, what direction? Anti-clockwise, that's it. So it's positive 90. So that's most of the information. But it's that tricky bit still left out. What's the coordinates of the centre? Usually a question like this, it's not going to make it tricky for you. It's probably going to be somewhere like the origin, or possibly 0, 1. So 1, 0, 0, 1, minus 1, 0, 0, minus 1. It's going to be probably one of those. So let's try for from triangle 1 to get to 2. Always worth, if it looks reasonable, start at the origin. Let's see what happens. You try it and you see, and well, yes, it works. So there we go. So the centre of rotation, 0, 0. Let's have a look at C as well. To get from 1 to 4. So again, start with a tracing paper on your object, and then you rotate it. Is it going to be anywhere near your image? Let's have a look. Well, how about that? Exactly on top. So again, 1 to 4 is 0, 0. Let's just have a look again at the what's the angle of rotation. It's gone from there, and to get to 4 we've gone through 180 degrees. If it's 180, we can just write 180. We don't need to worry about positive or negative, because if you go positive 180 or negative 180, you end up in the same place. Right, I've missed out getting from triangle 1 to triangle 3. Like I said, always worth checking, is it the origin? So until, oh no, it's not, it's gone past, way gone past it, hasn't it? So you can see I've got the right orientation there. I've gone from there to there, so that's 90 degrees clockwise, but nowhere near the right centre of rotation. So it's always worth trying one of these. No, that's not it. Try this one here. No, that's it. That's not it. But something worth remembering is that the centre rotation is the same distance from the centre of rotation to a vertex when it starts to when it finishes. And I can see both of those are quite close together, so it's going to be somewhere equidistant between them, the same distance between them. So I could try here. Right orientation but wrong position. Let's go back and start again. How about here? That's 1 square along from there and 1 square from there, so it could be, but no. What about this point here? 1 square from there, 1 square from there. It works. So what's our position? That's 1, 2. Last one to have a look at is going from triangle 1 to triangle 5. So that's where we're going. So we're starting again. We'll try the origin. Is that going to work? Not too far out. It's not right. Okay, just notice as well that's 90 degrees clockwise I've turned there, and that's the same orientation. So that's minus 90. But what about that centre? So again we can say, well, let's look at a corresponding point somewhere halfway between them. We could try what's 1, 2, 3, 4 squares, so 2 squares would be halfway between them. Be worth doing that 1, 1. Not quite. How about 0, 1? Did I try that one? Let's try that one. Nope, that's not going to be right. How about this point here? That's 2 squares diagonally to there from that vertex and the corresponding vertex. 2 squares diagonally. Let's try that one. Oh, and there we go, we've got it. So that is minus 1, 1.